Alright guys, we're going on to example number 3. So we're doing that same process. We got to find the solution to the system. So in this problem, we can see that the equations look a little different than before. This time they're in standard form. Okay, so we got the ax plus by equals c. So my first step, what I want to do is get it to a place where I can graph. But I know if I find the x and y intercepts, the first one, my x-intercept is going to be 12, and that's off the graph. I don't really want to do that, so I'm going to try and switch it to y equals mx plus b. So what that means is I'm just going to solve for y. So my first one, I've got x plus 4y equals 12. I want to solve for y, so I'm going to subtract x on both sides. So now I have 4y equals negative x plus 12. Divide by 4. So now I've got y equals negative 1/4 x plus 3. So there's my first equation. I'll go ahead and do that same process with my second equation. So I've got 3x plus 2y equals negative 4. So remember, I want to move my x over first, so minus 3x on both sides. So I got 2y equals negative 3x minus 4. Last step, divide by 2. So y equals negative 3 halves x minus 2. Okay, so now I've got my two new equations that I need to graph. So I'll go ahead and start with my red equation. So my y-intercept here is negative 2. And I'm going to go down 3 over 2. Remember, if you guys are struggling on how to graph these, remember this is a negative line. So that means if you draw two lines next to it, it should look like an N. Okay, so there's that one. 1, 2, 3 over 2. Alright, so here's this beautiful line. We're going to extend it all the way out. We're going to draw our arrows. And now we're going to graph our orange line. Okay, so our orange equation, we have a y-intercept of 3, which is here. Our slope is negative 1/4, so I'm going to go down 1 over 4. Or I'm going to go up 1 and back 4. And that's where you can see where it's going to definitely cross and intersect those lines. Okay, so here's that. I'm going to extend it out. I'm going to draw those arrows because these lines are going on forever. And now I'm going to look at my solution. Okay, as you can see, those lines cross at negative 4, 4. And that's my solution. The next problem, example number 4, is a word problem. So we're given two sets of information. We have to create equations, graph them, and then see where they intersect. So if we look at our first alligator, okay, we know that we have to label some variables. So let's have x equal time and y equal the weight. Keep in mind, this is over a 12-month period, too. So our initial weight for alligator 1 is 4 pounds, and then it has a growth rate of 2 pounds per month. So we know that y is our end weight, and we know that it has a rate of change of 2. So that's a 2x, because that 2 depends on how many months have gone by. But keep in mind that alligator started at 4 pounds, so that's our y equals 2x plus 4. So let's go ahead and graph that one. We start at 4. We go up 2 over 1. So there's my first line. Okay, my second equation is focused on alligator number 2. Okay, that one has an initial weight of 6 pounds and has a growth rate of 1 pound per month. So remember, y is our end weight. Our rate of change here is 1x, and our initial weight is 6. So we see that we're going to start at 6 on our y-intercept and go up 1 over 1. And that's the rate of change for this particular alligator. Alright, so let's see. I'm going to draw my arrows. All right, so one thing I want you guys to keep in mind is that the biggest part of focus is this part of our graph. If you have weights and you're talking about real life scenarios, there's no such thing as negative time and negative weight. So that's where we can just completely ignore these values. Okay, we don't want negative time and we don't want negative weights. All right, so if we look particularly close at this equation, or this system of equations, we can see that it crosses at about, what, 2.8? So if we're given the solution 2.8 in this equation, what does it mean? Okay, yes, you're given some values, and yes, you're given some numbers, but how can we interpret that? So we can interpret that by saying after 2 months, both alligators, I'm going to shorten it, were 8 pounds. And that's where they are the same weight. So that's a great way to interpret these sorts of graphs.